Riemann sums. Riemann sums are a method used to approximate integrals by summing areas of rectangles underneath a function. Given an integral, a Riemann sum can be formulated to approximate its value. The steps that form the Riemann sum method are: first, partition the interval a to b into n subintervals of equal width. This means the width of one subinterval equals b minus a over n. N is an arbitrary value, but the greater the value of n, the more accurate the approximation. Secondly, choose a sample point xi in each subinterval. This is the value of x, which acts as a representative of the entire subinterval. Then, form each rectangle's area with f of xi multiplied by the subinterval width. Lastly, sum the area of all the rectangles in the interval. There exist variants of the Riemann sum method based on how the value of xi is chosen. The left Riemann sum uses the left endpoint of the subinterval as xi. The right Riemann sum uses the right endpoint of the subinterval as xi. The midpoint Riemann sum uses the midpoint of the subinterval as xi. This method usually reduces error compared to left or right sum. Here is an example of a function to calculate a Riemann sum. We will use the midpoint variant in this example. On line 1, we import numpy under the alias np. This lets us use the functions in the numpy library by referring to it as np. On line 3, we create the function definition. This tells the program that we would like to create a function called Riemann sum, with inputs for the function that we want to calculate the area of, the lower and upper bounds of the area, and the number of rectangles we would like to use in the approximation. By writing n equal to 100, if no value for n is given, the default value will be 100. A key point to remember here is that the def keyword is always used to tell Python that the following lines are a part of a function. Line 4 starts with the hash character. This tells Python that everything on this line is a comment and should be ignored when running the code. This allows us to label our code by putting hash characters at the start of lines. Line 5 carries out step 1 of the method. Here we calculate the subinterval width and store it in the dx variable. Lines 7 to 9 carry out step 2 of the Riemann sum method. We calculate the midpoint of the first and last subintervals and store these values under the name first midpoint and last midpoint. We then generate an array of midpoints for each of the subintervals. This is achieved with the arange function from numpy. The arange function takes the first value, the last value, and the step size as inputs and generates an array of values. This array is stored under the name midpoints. Then lines 11, 12, and 13 carry out the third and fourth steps. The total sum of the rectangles so far is stored under the name total area. Before we have summed the area of any rectangles, this value is 0. Then, using a for loop, we set the variable point to each value in the list midpoints. As line 13 is indented, it will run within the for loop and will be repeated for every point in the midpoints list. Line 13 calculates the value of the function at the point multiplied by the rectangle width and adds this to the value stored in total area. After the for loop has finished, the value of total area is outputted. The return keyword tells Python that the function is finished and to output a value. A key point to notice here is that lines 4 to 16 are indented, which lets Python know that they are a part of the function. Line 18 is used to test the function. First, the print function is used to display the output. The Riemann sum function is called with 3 inputs. The first input is a lambda function. This can be used to quickly write simple mathematical functions in a short way. The function inputted is x squared. The lower bound is inputted as 0, and the upper bound is inputted as 1. We don't need to input a value for n, as the function can use the default value of 100. When this program is run, it will display a value very close to 1/3. Try writing and running this program, And if you have any questions, problems, or even if you want to know more about lambda functions, feel free to leave a comment and I will do my best to answer them.